let's finish up with the binomial theorem and how you can do your expansions. Okay, you can actually, what we were using with Pascal's, okay, you can actually use combination also. Okay, lots of times we're going to write it in this, the parenthesis and over R, just because the notation is just easier to do. But if you wanted to go through the process you were going through before, when we were doing Pascal's, you could do the combination for zeros and x for a sub 0. I encourage you to put this in your calculator and give it a try. Again, noticing how my exponents, or since we're doing a 4, are still adding up to 4. Then 4 take 4. And when you put that in your calculator, you're still going to get what we got with Pascal's, which is fine. You know, it may be simpler to do it the other way for something as simple as this. But then what happens when you get to higher up? Okay, so be careful with that. Now, look at this. We're going to do the third to the third power. And again, for some of you, it'll be easier just to FOIL that out, times 3. But let's see what this would look like if we were using the binomial theorem. Okay. Now, so we would start off with 3 take 0. So now the reason I want to show you this is be careful. This is a little different than x. When you do this right here, it's 2x to the third power, 3 to the 0 power. And then 3 take 1, that would give us 2x squared, and 3 to the first power. Just make sure you've got everything in there as you're working that. Okay. Then 3 take 2 would give us 2x to the first power, 3 squared, and then 3 take 3. Oops, I'm running out of room here. 2x to the 0 power, then 3 cubed. Okay. So 1, then 8x cubed times 1 plus 3 times 4x squared times 3 plus 3 again times 2x times 9, and then 1 times 1 times 27. So this would come out 8x cubed plus 36x squared plus 54x plus 27. Okay. X squared minus 4 cubed. 3 takes 0. And then we would get x squared cubed, negative 4, notice, negative 4 because it was minus 0, then 3 take 1, which will give us x squared squared, negative 4 to the first, 3 take 2, x squared to the first, negative 4 squared, and then 3 take 3. Remember, you're putting this in your calculator if you don't have the pattern memorized, and then that would be x squared to the 0 power and negative 4 to the third power. So 1 x to the 6th times 1 plus 3 x to the 4th times negative 4 plus 3 x squared times 16 plus 1 times negative 64. Oops. Remember how we talked about the signs would change, so here's a way that you can see why the signs are changing. Okay. And then the last couple just little tidbits of how this works. Okay. Is sometimes you're going to be asked to use Pascal's triangle, and it says use the fifth row to find the binomial coefficients. So we wrote you a note that this is the way the question is worded. It seems misleading. You use the fifth row to get the sixth row, because remember the fifth row is 1, 5, 10, 10, 5, 1. So this would be the fifth row, but we want the sixth row, so we use, remember how we were using this? So that's why you need to use the fifth row to get to the sixth row. Okay. So then it says use the seventh row to get to the eighth row. Well, luckily we have the sixth row right up here, so we can find our seventh row. 7 would be 1, 7, make sure I get this right, 21, 35, 35, 21, and 1, and then 8 would be 1, 8, 28, 56, 70, 56. Oops, I forgot my 7. There's a log right there. 28, and then 8, and then 1 again. I kind of ran out of room there. Oh, I didn't start over here. Okay, so that's kind of how that might look. Okay, and then if you're asked to find a term in the in a binomial expansion, so in the expansion x plus n to the nth power, the r plus 1 nth term is denoted by. Okay, so this is kind of a weird little formula that we do that. So right here, so where it says find the sixth term, okay, well r plus 1 is our sixth term, so we're going to say r is 5. So when I come over here, okay, we're going to do, so let's write this out, what it would look like. It would look like 8, choose r is 5, then x, that would be 8 minus 5, and then y would be 5. Okay, so that one takes a minute to look at. So if you do 8, choose 5. Okay. And I did x and y. What I really should have done was a, 8 minus 5 is 3, and then b, or 2b to the 5th power. Okay, so when I work on that, so 8 choose 5 gives me 56 times a cubed times 2 to the 5th power is 32. B to the 5th, so 56, so this would be the sixth term. If we were to expand it all the way out, this would be the sixth term. One of the things they like to ask a lot is they like to ask, find the coefficient A6, B5, what the coefficient would be on that. Okay, so 6 and 5 is 11, and remember this is our R right here. So we're going to do 11, choose 5, and then 3a to the 6th, negative 2b to the 5th. Okay, 11 choose 5, 462. 3 to the 6th power, 729. A to the 6th, and negative b to the 5th power is going to get, excuse me, I'm sorry, negative 2 to the 5th power is going to give me negative 32, b to the 5th. So the coefficient of that term, this is where this gets kind of crazy. This is where those of us who think this is kind of fun lose some of the people. They're like, really? But it is kind of cool. Okay. So take some time looking at that, practice your binomial theorem and your Pascal's triangle and all of this kind of fun little mathy stuff. See you soon.